11.1 square roots. All right, so to start off, we need to talk about some definitions. What is a square root? What am I talking about when I say the square root of a number? Square root of a number can be multiplied by itself to equal that number raised to the second power. What does that mean in a form of an example? You need to write at least one of these down. If 8 squared equals 64, then 8 is the square root of 64. If 9 squared equals 81, then 9 is the square root of 81. If 6 squared equals 36, then 6 is the square root of 36. If 2 squared equals 4, then 2 is the square root of 4. Basically, what I'm saying is that they work hand in hand, okay? So you can go either way as far as squaring a number or taking the square root of a number. And we'll show that in more detail in a minute whenever we go over example 1. So just get at least one of these examples down. You don't have to worry about the definition. Just get one of the examples down. Last two terms that you need to know, okay? What is a perfect square? The perfect square is when numbers that are squares of integers such as 1, 4, 16, and 25. It's the product of two numbers multiplied by themselves. That's a perfect square. So 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. All of these products that you see in bold print, these are what I call perfect squares. Now, you can take any number and multiply it by itself. So let's do like 16 times 16. Someone do that in your calculator. What do you get? What's 16 times 16? What is it?
122.
No, not even close. Put it in your calculators. Come on, I need to see everybody's calculator on your desk. It is 256. So I could say that 256 is a perfect square. Okay? Now in this section, this is all that we're dealing with is perfect squares. So whenever you're taking the square root of a number, it will come out evenly. Now it doesn't always come out evenly, and we'll learn that tomorrow in 11.2. But for this section, everything we deal with will be considered a perfect square, meaning an exact number is multiplied by itself to get to that product. All right, now the third term is a radical sign. All right, the radical sign square root represents a square root. So if I asked you, what is the radical sign that represents a square root? You would circle this. All right, so let's do example 1, finding square roots. All right, notice it says find the square root of 81. Okay, find the square root of 81. Well, I know that what number raised to the second power is 81. What's the square root of 81?
9.
It's 9. Okay, but it's not just 9. 9 squared, yes, is 81. But would it be true to say that negative 9 squared equals 81? Yes, it would. Because whenever I raise a number to the power, I'm essentially multiplying that number by itself. Well, negative 9 times negative 9, two negatives, even number of negatives, does equal a positive. Okay? So, in this type of context, okay, so whenever it's just saying in words, find the square root of 81, you are going to have two answers, positive and negative 9. Positive and negative 9, and this is how you would write it. Okay? Now in the second one, find the square root of 49. Well, I know the square root of 49 is what number?
7.
It's 7. So I could say that 7 squared is 49. I could also say that negative 7 squared is 49. Because again, negative 7 times negative 7 is positive 49. So I would say that my answer here is going to be positive negative 7. Okay? Positive and negative 7. Both of them could be the answer. Okay, now in example 2, now we're evaluating square roots. Okay, now a radical sign. What's my radical? It's the square root symbol. In and of itself is positive. Okay, so if I see a radical with a number under it, I know that I'm taking the positive square root unless there is a negative in front of it. Okay, so this is different from example 1 by just saying find the square root of 81. Here, it gives me a radical. Since I have a radical, I know in the first one that I'm taking the positive square root. Square root of 36 is what, class?
6.
It's 6. Square root of 16 is? 4. Square root of negative 16? Negative 4. That's how I know I'm taking the negative square root. Because there's a negative out in front of the radical, I know that my answer is also going to be negative. The square root of 0 is? 0. And now I want to take the chance in this last one, 625, to show you how to work this in your calculators if you don't know already. All right, so we all have different calculators. For some of you, you'll press the square root sign before you enter the number. For some of you, you'll press it after. So I'm going to go ahead and pause it and help whoever needs help figuring out what the square root of 625 is. The square root of 625 is what?
Negative 25.
It's going to be negative 25. All right, now remember, I'm taking the square root of these numbers, which means if I square any one of these numbers, if I square them, I should end up with the number that's underneath the radical. Is it true that 6 squared is 36? Yes, it is. Is it true that 4 squared is 16? Yes. Is it true that 25 squared is 625? Yes, it is. So they work both ways. All right? To square a number or to take the square root of a number, it goes full circle. All right, and we'll go into more detail on that concept in a minute. All right, now in example 3, we're looking at the pole vaulting example in your books on page 533. So read it with me. I want you to see where we're getting this information from. It says, you with me on page 533? It says, how fast should a pole vaulter run to vault over a height of 16 feet? All right, well, here they give us the equation. This is what they give us. S equals 8 times the square root of h. All right, so they give us the equation. The speed is S equals 8 times the square root, and I know the height is 16. Now, there is a way to just go ahead and put 8 times the square root of 16 into your calculator. Because everybody has different calculators, it's very difficult to teach that. So what I'm going to have you do, unless you can figure it out on your own, is go ahead and evaluate what is under the radical first. What is the square root of 16? What's the square root of 16?
4.
It's 4. Just 4. Because remember, a radical is positive unless we say differently. All right? So, equals 8 times 4, which equals 32 feet per second. Very unrealistic. We know that nobody can run that fast in real life. But, for example purposes, that is how we would solve a word problem using a radical. In example 4, so examples 1 through 3, we dealt with radicals by themselves. Okay? Finding the square root of a number, is it a positive and negative, or evaluating a radical, that type of thing. Well, now in example 4, we're evaluating radical expressions. Well, a radical expression is basically, well, an expression we know is 2 terms combined together by some kind of operation. Addition, subtraction, multiplication, or division. In this case, it's going to be addition. So I need to do, just like I've been doing all year, I need to substitute these values in for the variables and then solve. All right, so in A, I have the square root of 29 plus z. I know that z equals 7, so the square root of 29 plus 7 equals the square root of 36. And the square root of 36 is what? It is, class? It is 6. So that would be my answer. All right, now in B, it's a little bit more complex. In B, it says the square root of z squared plus m squared plus 11. So again, the first thing I do is I make the substitutions. So I have 7 squared, and remember to put these in parentheses, plus negative 2 squared plus 11. All right, and now I need to evaluate what's underneath the radical before I take the square root. So 7 squared is? 7 squared is? 49. Negative 2 squared is? Is it negative 4 or positive 4? Remember, the reason I put it in parentheses is to show that I am multiplying negative 2 by itself twice. So negative 2 times negative 2 is what? Positive 4. 2 negatives, even number of negatives equal a positive. All right, that's why it's important to put it in parentheses. Okay, so it's 49 plus 4 plus 11. And what's 49 plus 4 plus 11?
64.
And the square root of 64 is? 8. All right. Now in your homework tonight, they all work out very beautifully, just like this, in whole numbers. So you're not even dealing with decimals or anything. So if you do come out to have a decimal, you know that you got the wrong answer somehow. Okay, so that can be a way that you can check your work. All right. In example 5, now we're solving an equation using a square root. But before we do that, I want to kind of review something with you real quick. What if I had 5x equals 30? How would I solve for x?
Divide by 5.
I would need to divide by 5, right? And why do I want to divide by 5? Why not divide by 30?
Get x by itself.
Because the whole goal is to get x by itself. All right? Well, it doesn't change here in example 5. My goal is to get x by itself, but now I have a pesky little exponent up here. So how do I get rid of an exponent? I can't just divide by 2. I have to, what do you think? Take the square root. I have to take the square root. So to get rid of x squared, I have to take the square root of both numbers. Because, remember, my rule still is the same. Whatever I do to one side, I have to do to the other. The square root of x squared is simply x. And the square root of 25 is 5. Stay with me here. The answer is going to be positive and negative 5. And here's why. How do I check to see if my solution is correct when working in an equation? How do I check my solution? Kathy?
Put 5 as x.
Okay, plug it back into the original equation. So that's exactly what we're going to do. 5 squared equals 25. Was that true? 5 squared equals 25? Yes, it is. 25 equals 25. It checks out. But what about negative 5 squared equals 25? What's negative 5 squared?
25.
25 too. So even if I plugged in negative 5, it still checks out to 25 equals 25. So my solution is positive and negative 5. All right? In B now, I have h squared plus 5 equals 54. But what do I need to do first? What's my first step here, Andrew? I need to get rid of the 5. How do I do that? Okay, I need to subtract 5 from both sides. And I get h squared equals 49. All right, now how do I get to my solution? How do I get h by itself? How do I get h by itself? Kathy?
You divide.
Nope, don't divide.
Divide.
Nope, don't multiply. I do the, what am I learning about this lesson? Nope.
Square root.
The square root. The square root. How do I get rid of an exponent? I have to take the square root in this case. So I take the positive, negative square root of 49. Okay? So h equals, what's the square root of 49?
7.
Positive or negative 7. And here's why. I'm going to show you again. If I were to plug in the numbers, 7 squared plus 5 equals 54, or negative 7 squared plus 5 equals 54, they both work out. 49 plus 5 equals 54. 54 equals 54. Checks out. And 49 plus 5 equals 54. They both check out. And if you understand that, that's everything you need to know for 11.1.